Assalamualaikum and hi. A very good day to all of you. Alright, I'm Shikin Aziz. We meet again here in YouTube, my YouTube channel. Alright, so this is my next recorded lecture. Okay, uh, and today the topic is on steps to effective silo design, and this is actually a materials for my class. The code is EPF 4801 process equipment design. Okay, this is actually a lecture for my undergraduate students. All right, during the MCO. Uh, Due to COVID-19 pandemic. All right. Oh, by the way, reference for today's lecture is you can refer down there at the description box. For the main reference for today's lecture contents, uh, mainly I referred this article from Chemical Engineering Progress magazine, published by American Institute of Chemical Engineers. All right. Okay. So this article been written by the Director of Education of Janai K. Johansson's, Mr. Eric Maynard. All right. And to be honest, I'm not necessarily expertise on this. So this lecture content, I'm purely depend on this article, and I hope I can deliver the knowledge good. Okay, I can deliver this knowledge to to you, all of you. Okay, so before we proceed further, let me tell you. Okay, uh, in order for you to design, okay, bulk solid storage, okay, a lot of consideration need to be taken care, to be taken care, okay, because uh, the bulk solids, okay, the bulk solid as we've been as I have been delivered during my previous lecture. Okay, bulk solid is quite complicated compared to liquid actually. All right, the properties is not straightforward. Okay, for you to understand. Mainly we need to do some tests on the bulk solids, okay, to understand the behavior of the bulk solid, okay, to understand the properties of the bulk solids. All right. Okay. Uh, without the knowledge on a good design of bulk solids storage equipment, all right, uh, a lot of problems can happen, okay, such as no flow from your storage equipment. So this is not good actually, because it will affect a lot of things, your production. The production will delay, and then sometimes it can cause a shift, a segregation. So basically, uh, what you will get from the discharge of the powder storage uh, is not homogeneous, or in other words is not uniform. So the properties inside there is not uniform, so this is totally not good. Okay, it will affect the quality of your product. Okay. So without taking into a lot of consideration before designing the equipment is actually uh, a trouble, okay, trouble at the end of your, when after you having the equipment. So sometimes you need to you need to rebuild the equipment, so this will of course incur a loss of cost. All right. So the article that I referred, okay, will give you an idea, step by step, the best practice to design bulk solid storage. Okay, or in other words, a silo, or you can call it bin or hoppers. All right. The first step that we need to do is to define the storage requirements. All right. There are 6, okay, consideration that need to be reviewed before you design the storage for your bulk solids. All right. First things that we need to see is we need to review is storage capacity. As I said in my previous lecture, all right, transportation method is greatly affect your sizing, the sizing of your storage, all right, because we do have a lot of transportation type, truck, it could be ship, it could be aeroplane, all right. So we need to know the capacity of our transportation, and then we need to consider once we receive the product, whether can we store in our equipment. So then the other things that we need to consider is it enough to have only one silo, or maybe we need to have more than one silo, because it's ridiculous to build a big silo, because of course the cost it will be greatly expensive, all right, because you will need a very good structure of the silo if you having to hold a very big capacity of your raw material. And then another things that we need to consider is the location of our silo, either it's indoor or outdoor, all right. Because the environment, okay, the environment of this the environment outside of the silo would be totally different, if we compare indoor to outdoor, right? And then what is our then the next things that we need to consider to review is the discharge frequency and rate. How long will the bulk solid remain in the silo, okay, without movement? And then other thing that we need to think about it is what are the maximum and minimum average and instantaneous discharge rates, right? And next is what is the unit that we are using, the mass or volume, and then what is the required feed accuracy, okay. Right. Then for next consideration is on the temperature and pressure, because some raw material will require a different temperature and pressure for storing, right, in order to maintain the quality of the raw materials. And another things that we need to consider is the material being fed into a positive or negative pressure environment. This is especially important, especially if, let's say, the next process will involve reactor or pneumatic conveying line. uh, Fabrication materials, and it's another consideration that need to be taken care. All right. You need to know the behavior, the properties of the raw material of your bulk solids, either it's corrosive or abrasive, okay. So example of abrasive, let's say alumina, iron, so corrosion, and then do you need a corrosion resistant alloys, and then ultra high molecular weight plastic liner acceptable, okay. So these plastic liners are basically another technology that being used in industry, where they coated the equipment in order to enhance the flowability of the bulk solid inside the equipment, something like that. All right. And is the application subject to any regulatory compliance, okay, such as US Food and Drug Administration, Food Act, okay, in Malaysia Food Act, let's say and then other things, in Malaysia is Food Act lah, for if let's say contact if it's in the food, all right. Okay. uh, then next, another thing that we need to consider is the safety and environmental consideration, okay, whether the bulk solid it is a explosive material, okay. I hope you are not surprised that actually some of the food powder as well can be can be as can be explode. Eh? All right. Due to the very dry condition and electrostatic. All right. And then, do we have any maximum dust exposure limit? So this one we need to refer act under environmental act, right? Or any other safety or environmental issues that we need to consider. Okay. All right. Then, but solid uniformity. Okay. Okay. Uh, so we need to review the uniformity that we need for our raw material, okay, before further process, or for our, if let's say the raw material, let's say for our end product, all right, if let's say we are producing a infant formula, or milk powder, okay, cow milk powder. So we need to know what is our uniformity targets. Okay, is it what we need to take in care? Is it a particle size, shape, potency, or moisture content, or color? Or could be the contents. Yeah, the uniformity of the contents. Okay, so then is the particle segregation likely with the material? Okay, yeah. If let's say this can happen, and then we need to know how will segregation affect production and final products. All right. So mainly in food industry, we the segregation is not is not a favor. Okay. We will avoid segregation because it will affect the qualities of the product. It will affect the uniformity of the contents. For example, the content inside the pharmaceutical product, right? Of course, we don't want the content is totally different between one batch to another batch of vitamin C inside the bottle. Okay, I hope you understand this. All right. Okay. Then next, the next step is uh, we must know, okay, and then understand the bulk solid flow problems and how it will affect the flow performance inside the equipment. Okay, so some of this term has been introduced in previous lecture, and it has been explained thoroughly actually, and I will not explain thoroughly again here. Right, you can refer my previous lecture. So like arching, bridging, okay. Then another thing, right hauling, flooding, or flushing, all right. Okay, so and then flow rate limitation, particle segregation. So I will only explain those that I has not yet explained from the previous lecture. So for example, arching and bridging and red hauling, I think I have been explained thoroughly in the previous lecture. But for flooding and flushing, okay, I will explain here. Okay, so flooding and flushing is basically is a condition in which an aerated but solid behave like a fluid and flows uncontrollably through an outlet of feeder. You can see this phenomena. You need to visit Janike and Johansson YouTube channel. They have a video of that. Okay, all right. And then flow rate limitation. So flow rate limitation here, all right, is actually an insufficient. Okay, an insufficient flow rate. Okay, typically caused by counterflowing slowing the gravity discharge of fine powders. And then another thing is here particle segregation. All right, is separation of particle by size, shape, density, and etc. Okay, so basically particle segregation may prevent a chemical reaction and cause out of spec product, or sometimes it require costly rework. All right, costly rework. So, right, all right. Then step 3. Okay, step 3 is we need to measure the flow properties of the bulk solid. Okay, A good practice is to measure the flow properties of the bulk solid. Okay, every time you receive the new raw material, you must do the test. All right. Or every not receive raw material. Every time you want to design storage for bulk solid, you must test, okay, the bulk solid, okay, that you're going to contain inside your equipment that you're going to be designed. All right. So of course there are some literature available, or reference that you can refer, that maybe the properties is similar, but my advice is to test the bulk solid properties that you're going to contain inside your equipment that you're going to be designed, because different different powder, even though it's a have a similar powder, even though it has a similar chemical content, but it will not give the same flow properties. So remember, make sure for the real practice is for you to get some sample of the bulk solid first, and then do test okay, before you design the equipment, in order for you to understand the behavior of the bulk solid. All right. All right. So, but for your case on plant design, I allow you to find any reference. Okay, reference from the literature. Of course, we don't have the time to do the testing. Okay, and some of you have not yet taken the subject of particle technology in order for you to understand all these parameter. All right. So So the flow properties of the material, okay, must be measured in order to predict and control flow, how it will behave in a silo. Okay, so these properties, okay, these properties can be measured in a bulk solid testing laboratory. Okay, under condition, and then another thing that you need to remember, during your testing, you must make sure that the condition during the testing are the same or similar to the environment where you're going to handle the material later on. Okay, so basically, in order for you to simulate, okay, because we must understand that powder are very sensitive to environment. Okay, they're very sensitive to moisture. All right. So caking is common problem in fine powders. All right. So you need to ensure during the testing you simulate the same environment uh, with what with the environment of your process industry, okay, or your process facility. So all right. So and then this table showing the most important bulk solid handling properties, okay, which are relevant to predict flow behavior in silo. Okay, and then so we do have cohesive strengths here. uh, okay, so we have cohesive strength. So why we need to understand the cohesive strength is basically this cohesive strength it will give this parameter will give an idea how you can avoid arching and red hauling, okay, problems. All right, and then by having a parameter of wall friction, you can predict, okay, or you can you can predict, or you can diagnose the flow pattern. Okay, you can, okay, and then you can plan what to do, okay, what is the best design in order to get a certain flow pattern inside the silo. And then bulk density. Here, compressive specificity is required to calculate pressures, bin load, design feeders. For permeability, normally for fine powders, okay, it's calculate discharge rate and settling time. While segregation tendency to predict whether or not segregation will occur. Okay, and abrasiveness here to predict the wear life of a bin liner. All right, and then sliding at impact points. This is to determine minimum angle of chute at impact points, and particle friability to determine effect of flow pattern on particle breakage. So this is the equipment, okay, that available to be tested. Okay, the name of the equipment. All right. So you can get a lot. You can learn detail of this parameter because this is will not be covered under the EPFO 801. But for the fundamental of this of the powder, okay, the parameters of the powder, you can get this knowledge. Okay, you can enrich your knowledge by taking the EPFO 705 particle technology. Okay, this course. All right, then all these parameters, okay, can vary, all right, with changes in moisture content, particle size, temperature, storage time, and chemical additive pressure and wall surface. All right. Then step 4. Step 4 is to calculate the approximate size of the bin. Okay. All right. So this is the formula to calculate the approximate height of the cylinder section. All right. For this formula, is actually to calculate only on the cylinder section, where hopper section is ignored. Hopper section is the part, okay, the conical part, or the wedges part, okay, the wedge part. Okay, so here we have H for cylinder height, and then M for the mass to be stored, and then this rho for the average bulk density, and A for the cross-sectional area of the cylinder section. Okay. So okay. Because the design process of bulk solid storage is iterative, all right. So basically, a reasonable estimation for cylinder height, okay, is sufficient enough for this point. So this is just estimation first, because there is the calculation for bulk solid storage is iterative. So first we need to estimate, okay, the height. So we're using this formula. Okay. All right. So the actual cylinder height will have to be adjusted to account for volume loss at the top due to the material's angle of repose, as well as for the volume of material in the hopper section. All right. So economical practice, the height of circular or square cylinder should be between 1.5 and 4 times the cylinder diameter or width. Okay. All right. Okay. So so common practice, if the value is outside of this range, if the value is outside of this range, often the design will not be uneconomical. So this is be reported by the industry article. And then note that the silos calculated storage volume, okay, and its life or active, okay, or usable volume are not necessarily identical, because due to the stagnant region. Okay. All right. This is an issue. This is common issue in bulk solid storage, which is totally different if you compare with the liquid, because liquid we don't have a stagnant region in liquid. Okay. Okay. Then step 5. It is to determine the type of flow pattern needed. Okay, to determine the type of flow pattern needed. All right. So I hope you know by now what is funnel flow, what is mass flow discharge, as I has been introduced you in the previous lecture. Okay. So both of these flow discharge have the advantages and have disadvantages. But for food process, the best flow discharge pattern is mass flow. Okay. 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 So here in this lecture, I will going to introduce you this flow chart. Okay, this flow diagram. Okay, flow pattern selection diagram. So this giving an idea how to select and how to determine which flow pattern is the best. So by considering the segregation, uh, by uh, by considering all the question, okay, the 4 question here. So the first question here is segregation important, okay. In food industry, of course, segregation is important. We have to avoid segregation. So if yes, then you will need to use mass flow design, bin design. But then next, will caking or spoilage occur? Of course, in food industry, it always happen. Okay, so yes, again, we need to choose mass flow design. Is flooding likely? I think yes, especially for fine powder. So then we need to consider mass flow again. And will rat hauling occur? Of course, again, yes. Rat hauling is a common problem in fine powders such as coconut powder, okay, coconut milk powder, cow milk powder, right? We have Milo powder, is common. So then next, when we determine that mass flow bin design is important, and then we need to check is the outlet enough for the rate. If let's say yes, then we need to find the feeder speed. Is it reasonable or not? If it's reasonable, yes, then we can get a mass flow bin design. Okay, but if let's say the outlet is not large enough, we need to enlarge the outlet or use fluidization. Okay, we need to add up fluidization and equipment there. Okay, if let's say the feeder speed is not reasonable, then you need to change to the different type of feeder. So you can see here how feeders are also affecting the our design. Okay, the silo design. All right. So it's not totally depending on the silo itself. The silo, we need to also to consider a best selection of feeder. Then mass. Okay. So you know by now that mass flow silo will give a first in first out, while funnel flow will give filo. Okay, the FIFO, the filo. Okay, it sounds so cute. All right. The short term. I'm using the short term. Okay, so the outlet design, commonly for mass flow silo, we're using a conical discharge, a circular outlet, or with a non-conical discharge with wedge shape outlet. And this is the common outlet design for in order to get a mass flow silo. While for funnel flow silo, they are commonly use the design commonly use a circular outlet or rectangular outlet. All right, class. Okay, class. I think we have to stop up till now. Okay, we look 5 steps only for this lecture. We will continue to the next at the next video for another 5 steps. All right. All right, because I'm running out of times. Yeah, I have to make sure the video is quite small. Okay, so to assist my ni to ensure that I can successfully save the video. Okay, we will see uh uh in next video. Okay, part 2. All right. See you again. Bye. Assalamualaikum. Take care. Stay safe.